Thanks, Matt. Thanks for organizing this great session. So everyone, my name is Simon. I'm working at the Esri R&D Center in Zurich. I have the honor to represent the CityEngine development team at this user meeting. And they trusted me in talking about Python 3 and also a bit what's new overall. So of course, Python is just one of the areas we've been busy working on the last couple months, even years. So I'd like to take a few minutes first to highlight, I guess, three key improvements in 25.1. So one is CJ itself, one is about Visual CJ, and then the Street Designer, as Devin already mentioned. So let's see here. So what you see here in action is the new CGA modify operation together with the inline recompose operator. So that's quite a mouthful. So inline was there before, but now we have a new mode for inline, which is recompose, which basically allows you to retain the topology or the mesh or the object granularity after you've modified a shape. So with modify, you can now really, simply said, move individual points for the first time. So this is a huge step for CGA itself. And so combined with the Boolean operations, you're now really able to express the overall design idea of a building and to really kind of capture what maybe an architect or what a designer has thought when putting all these shapes together. And then you can add nicely with something we call like inline or sequence programming. You can then add details afterwards. So this allows you to do organic designs on massings, but of course you can also do that on facades, as you've seen here. You can do pretty exotic stuff like these hexagon patterns or using mathematical expressions, sine waves for your facade designs. And by the way, the new modify and inline recompose operators, and also to a certain degree the Boolean support, these are all results of our 24 SIGGRAPH paper with the title Recompose Grammars, authored by Niklaus Huska and then Matthias Buehler et al. And it's really nice to see this kind of academic research now being put into production and being put to work. So we have combined all of that into a nice new example. It's called the Architecture Park, and it will be available for you to download in CityEngine 25.1. So you can explore and learn how this new inline way of writing rules works. And also this example includes everything nicely packaged in Visual CGA nodes. Talk about in a second. So you can start playing Lego with these now powerful building blocks. Speaking of Visual CGA, so we move up one level from CGA to the Visual CGA kind of user level. We added a lot of improvements to this and also included more bundled content like pre-designed facades, so to say, or the facade building blocks. We call them facade components in EsriLib. So it's now easier than ever, more easier than ever for planners and designers to kind of turn schematic designs into more realistic visualizations. And also you might notice these smaller kind of exit ports on the components. These are called parameter connections. And now you can actually share information from one component to another more easily and have kind of flow, almost like a flow of information in your design. And last but not least, we also added inline documentation. So the components now have a little information icon, which will display a nicely formatted documentation section about each node. Moving forward to Street Designer, this is our bespoke tool to design lane configurations and the cross sections. And so to enhance this design process, we added a lot of object attributes to each lane which makes a lane more aware of what it is actually. So you can then use CGA more efficiently or more effective to really model the purpose of a lane. We also improved a lot under the hood to improve performance and so on when you modify a street with models on top of them, or when you modify lanes with models already generated. Now, let's switch gears to Python. And before I jump into Python in CityEngine, I would like to take a second to establish the landscape a bit, what Esri has to offer in terms of Python overall. And so kind of in the family part of CityEngine, there is the PyPRT API. This is a Python library which closely follows what these procedural runtime C++ API has to offer. You can think of it as the kind of CGA execution part from CityEngine. So you feed it a footprint of a building, you apply your rules in form of an RPK, a rule package, which contains all the assets, 3D assets needed for a building. And then the procedural runtime, PyPRT, will spit out the 3D models, basically. Then widening the scope, we arrive at the ArcGIS platform. And this is really the workhorse for managing and analyzing WebGIS data and do the administrative parts, setting up databases, creating web maps, building applications with Python, which consume features or which consume layers. And you can also create maps. And then the hardcore GIS part is the ArcPy library. This is more or less what ArcGIS Pro has to offer in a programmable form. You can really use all the algorithms, all the geoprocessing toolboxes on your geodatabases and do the heavy lifting, basically. This is kind of the landscape where now CityEngine comes in with its new Python API. So far in CityEngine, I think it's good to kind of split what we have into two blocks. One is the actual developer environment. We call that the IDE, the integrated developer environment. This is where you write and run your Triton code until now. And we have the API, which is the actual functionality of CityEngine. So what's changing in 25.1 is now that we added Python 3 support for the IDE, as well as package management and virtual environments. More on that in a second. And of course, for that to work, the API itself also needs to be aware of Python 3. So we now have like a standalone CityEngine API package for Python 3 environments, which internally, of course, then talks to CityEngine and runs everything. Let's take a quick aside because while most of you are probably very familiar with Python already, it's important to kind of acknowledge that here it's quite a shift for CityEngine itself, because we're also changing the language level of Python as well as the flavor of Python, so to speak. We go from Triton to CPython as well. And so this is, of course, not a comprehensive overview, but I just want to make you aware or tease you some of the things you need to be aware of when going into Python 3 land. So Python 3 or print is now a function. This is kind of the classic example. Yeah, this is pretty straightforward, just a syntax change. Then a bit more subtle already is that, for example, the keys member function of a dictionary, before this was self-contained list of values which you could sort, but now it will only kind of return a reference or a view onto these keys for performance reasons. So if you want to have like a separate sorted list of your keys, you need to do this a bit differently, and Python 3 has tons of features to help you do that and have a more efficient code. Not an interesting tidbit is that There's no long anymore. It's now everything is now called int, which can represent a large range of values. And also the integer subdivision before was automatically truncating, but now in Python 3, integer subdivisions will turn into floats if necessary to not lose any precision. And then there's a huge topic on text and strings. I just leave you with a few quotes here. This has changed drastically. Basically, everything is now Unicode in Python 3, and you can use functions to turn into binary representations back and forth. As where before, there were some really subtle things going on, which led to a lot of problems. So this is simpler, but has a big impact on existing code, or can have. So I really encourage you to check out the Python docs about these changes. Now we are almost ready to jump into CityEngine and get to the nitty-gritty. But before that, we need to talk a bit where you actually get all these nice third-party packages from and how you integrate those. And so we need to establish a few things and names which we will use a lot in the following sections. So there are two big package repositories for Python. One is called PyPI. It's the Python Package Index. This is where you use tools like pip and uv to download and install packages in your local environments. One example is our own package, PyPRT, as just introduced. We publish that on this PyPI, and you can then easily download it with a single click or command. On the other side, we have Anaconda, which is the repository used by tools like conda.exe. And this is a different approach to managing packages. Anaconda is actually not just Python only. It's also used for binary packages implemented in with different technologies. And here an example from Esri is, for example, ArcPy. So the API for ArcGIS Pro. There our colleagues chose this way of representing the package because it allows them to also package the internal binary dependencies which ArcPy needs to work. So they have kind of this wider scope beyond Python at this point. Now we're finally in CityEngine. So we added a new UI in 25.1 in the preferences to manage Python interpreters, or more correctly, I should say, to manage virtual environments. So what you see here is actually representing the base Python.exe, but it's actually part of a virtual collection of packages. So CityEngine API itself is one such package, which is always present. And you see here, we are at version 0.5, so that's hence we are calling it a beta. And these are the packages visible to your scripts. So this is now a kind of a big change. Now you are in control of what packages your scripts see and can use, of course. And this UI allows you to also have custom environments and so on. More on that in a second. So I introduced these two repositories, PyPI and Conda. Hence, we also have two ways or support for both, I should say. So here you see the PyPI in action with the tool pip or UV. For UV, we do not yet have a UI, so you can also do that on the console, on the CLI, of course. So here you see an UI which helps you install a package. Here I'm trying to install ArcGIS, but it's already there. So it tells me, yeah, it's all there. Requirement satisfied already. And for Conda, a quick aside here, ArcGIS Pro has its own UI for Conda, so you can conveniently clone an existing Conda environment in ArcGIS Pro. Then you have all these packages here. You see ArcPy itself is here. And then you can use that, or you can do it on the CLI, of course, but you can typically use that and then add it to CityEngine. For example, here I'm adding the Conda exe from Pro to CityEngine, and then CityEngine knows, Pro has these kinds of environments available, and I can use them. And now you have ArcPy inside CityEngine and can do all the things Pro can do on your CityEngine data, for example. And this is really exciting for us because this brings all our own tools much closer together, with a better integration. Now, the most important stuff, of course, running your scripts. How do you do that now? Well, it's basically the same as before. One of the critical changes here is that the package is now called CityEngine, whereas for Triton it was called or is called scripting. Again, the Triton API itself does not go anywhere. It stays right here for you to still use, of course. A new change is that you can now use the project properties to specify under which Python your scripts will run. So here you see the two environments we configured before in the preferences. All the rest will stay the same. So in the same way, we let you specify which Python you want to use in your script runs. We also can use this in the consoles. So in the interactive console, so the bottom one here, you can specify which Python you want to use when you create an interactive console. In this case here, I created a console for the default Python. By the way, we will ship with Python 3.11 and 25.1, and we kind of try to use the most important Python version also used in our sister applications like ArcGIS Pro. We also added a few new buttons and controls. It's now easier to see if scripts are running in parallel. For example, if you have like a server-like script running in CityEngine, it's now easier to start and stop these. Now let's have a look at the demo. So I chose to show you kind of the classic use case of using procedural symbology on a feature layer. So here we need 3 ingredients for that. So we need a data source already shown here in this map. We need a way to fetch this data into CityEngine, and we need to do procedural symbology, which is, of course is CGA. So here's the data source. This is a kind of a live-ish feature layer of shared vehicles in Switzerland. It's an open data layer provided by the Swiss government through its open data portal and kindly periodically published by our friends over at S3 Switzerland as a feature layer in the Living Atlas. So you basically have 3 different symbols for car, bike, and scooters. You know, these things you always stumble over at the unexpected locations. At least that's how it is in Zurich. So now we have the data source. We need to find a way to get it into CityEngine. And that's, of course, the ArcGIS API for Python as introduced earlier. It lets you run, for example, a query command. So you give it a extent in the appropriate coordinate system, and it will return all the features inside that extent. And this is what we're gonna run in CityEngine. And then I wrote a basic script in CGA or a rule set to have nice little icons for these 3 types of features. Just an inverted cone, basically, with a little GLB on top, GLTF on top, and placed at the location where the point is. All right, so let's have a look. So we start with the base map of Zurich, which is the neighborhood where our office is. So we can, let's see if they wave back at us. Oh yeah, there we are. That's where CityEngine is created most of the time. So next we define a work extent. So this is the area we want to get the features. Before we run it, let's have a quick look at the code on the highest level. So the main function, as usual, we get the CityEngine runtime object. We have a function to get the extent from the selection in this local projected coordinate system. We log into the ArcGIS platform using the ArcGIS API for Python. We get the item from the Living Atlas, get a feature layer, and then we query it with the extent and the CityEngine coordinate system, basically. And then we create shapes out of it and design the CJ rules. Then I'm hitting F5, F9, as you all know, and it runs. This is moderately sped up. We're logging in to ArcGIS Online. We get 1,400 shapes back. We assign the rules, and we get a new output shape layer. Then let's zoom into kind of a busy section, our neighborhood, where there's a local train station. This is typically where everybody dumps their scooter. So let's look at one of them. So while the locations are plausible, I'm not so sure how exact they are, but yeah, plausible it is. I walk a lot there. And we can also cycle to the different symbols. Classic procedural symbology use case here. And zoom out a bit to see the whole thing. And so for those of you who are interested, I'm going to share this project together with the video of the talk. So that's already all I have. So these are the key takeaways. Sorry. So the key takeaways are, of course, we now have Python 3 support in the IDE and in the API. And I invite you all, while it's still beta, to start working with Python 3. It's actually already out there for more than 15 years. So we are a bit late to the party, but we are here to stay. I'm really excited to first mature now this Python 3 support and then start expanding the API with all these exciting opportunities it provides. So I would like to conclude with thanking my team, Christian, Matthias, Jen, and Nick, for all the incredible work they do, which I have such an easy time to show to you. Thanks, everybody.
Very, very nice. Thank you so much, Simon. There's just a question which came in from Patrick Gehigen, whom I also know, which is really nice. It's been some time. So Patrick writes, great to see you, Simon. Your demo may have answered my question. I need to change the rendering part of a CGA generated 3D model based on the value coming from a real-time feed. Could PyPRT be used to connect to a velocity feed feature layer, read the latest value on the asset, and update the rendering of the 3D model based on that value? This is a digital twin 3D need I'm seeing with airport clients who have enterprise IoT brokers and want to see 3D models that update in real time or near real time in their Esri 3D dashboard.
So the easy answer is yes, but then of course it depends. So as mentioned, PyPRT is like the standalone counterpart to what it's available inside CityEngine. So if your app needs to be standalone with a custom UI written in Python, then yes, PyPRT could be a solution. Otherwise, you could do the same in CityEngine. You could implement a small script which periodically listens to velocity or an event source changing and regenerating the CityEngine scene. It really depends how your application is architected at this point.
I'm pretty sure there's also kind of server-side solutions which would be feasible for this use case, right? Or in general, the rest of the ArcGIS platform, because I guess in the end it also depends a little bit on where. Let me open up the comment again. Basically, Patrick mentions kind of the Esri 3D dashboard, so kind of what that represents, whether this is in like a 3D representation, 3D GIS, or whatever basically the visualization context is, right? But
yeah, of course, I have now I have now my CityEngine hat on, and of course, there's tons
Yeah,
of alternative ways to implement
yeah,
that
yeah,
in
yeah.
the Azure ecosystem.
Which is really cool, right? So there's and that's kind of the power that is also now CityEngine is much closer to all of the rest of the ecosystem, and obviously this goes both ways. Yeah, yeah, very cool. I'm super excited for also for the or because you also showed the CGA changes, and I can't also wait for the next steps in the on the street side, and the everything Python is also most welcome. So
Mhm.
really cool.
Yeah, it's quite exciting. It's just we're just scratching the surface now.